Let's continue from where we left yesterday. Yes, very good morning to all of you. So let's continue now. So yesterday we were solving this question. Number 4, right? Number 4. Okay, now let's see how you could do number 4. So again, I would insist that when we solve physics questions, we must have a diagram, right? So this is the diagram we're talking about, right? Okay, so this was regarding 3, right? The question 3. Now we in the question 4, the difference is that we have to find the displacement from 10 second to 20 second after the start, right? So if I just draw one more diagram here so that you know it would be easy to talk about. So let's say this is where the vehicle started at A, right? Okay, this is at time t equal to 0. After 10 seconds, that is when time is 10 seconds, let's say the vehicle reaches here C. Okay, and finally at 20 seconds, the vehicle reaches B, right? So now we want to find out how much is the displacement of the vehicle between 10 seconds and 20 seconds, right? This is the question. All right, this is the question 4. Okay, now, so what we are going to do is, the plan, listen to this, the plan is that instead of finding this, right, instead of finding displacement from 10 second to 20 second, we will rather find this. All right, so let's call this delta x2, right, and let's call this delta x1, means displacement in the first part. So if we find this, and we have already found out the total, right, we have already found out the total, it is 300 meter, correct? So the plan is that if you want to find delta x2, right, that's our answer, then that delta x2 should be equal to 300 minus delta x1. All right, is this clear, everyone? Okay. All right, I'm waiting for your response. Have you understood what I said? I'm saying that if you want to find delta x1, we have already found this in previous question, right? 300 meter, it's right here. So based on that, if I want to find delta x2, I can just subtract delta x1, right? So if we do it this way, then we can easily get it. So let's find out delta x. Okay, let's find out delta x1 first. So what is delta x1? Delta x1 is nothing but the displacement from 0 second to 10 second, correct? Displacement from 0 second to 10 second, that is, this is initial and this is final if we want to talk about delta x1. So, and we know acceleration is constant, so we can use the formula v0 t plus half a t square, right? This is the second equation that we have derived. All right, let's put values. Initial velocity means here at A, when the vehicle starts, the velocity is given to be 0, right? It starts from rest. Okay, so 0 into anything, 0 into anything is 0, plus 1 by 2 A. Okay, what is the value of A? I think it is 1.5. Right? Now, what's the value of t? Come on, people. Can you tell me what's the value of t? Can you tell me what is the value of t? Very good. 10 seconds. Well done, people. It is 10 seconds because we are talking about a time from point A to the point C, right? We're talking about time interval from A to C because A is initial and C is final. So the time interval is 10 seconds. So if you do it this way, you're going to get 75 from this calculation, correct? You get 75. Okay. So now delta x1 is 75 meter. All right. So our answer What will be the final answer? Can you tell me that now? What will be the final answer? If this is 75 meter, what will be the final answer? Yes, Divya, well done. Kathan, well done. Yes, Pina. Unit, Dikshita. Okay. People pay. Please be careful in addition subtraction. All right. So the answer is going to be 225 meter, right? All right. 225 meter. That's the correct answer. Okay. Right. So this is how you could do this, right? Okay, of course we are going to do a lot more of questions like this, right? Okay, so let's continue with the third equation. See, we have already derived two. First one is v is equal to v0 plus 80. Second one is delta x equal to v0 t plus half at square, right? Okay, now it's time for the third one. I asked you to derive the third one on your own by substituting the value of t from first equation into second equation, right? So I'm showing you the steps now. Okay, the third one. So from first equation, t is equal to v minus v0 upon a. I'm sure all of you understand that, right? So now if we continue from second, right? So I'm going to put this value, into second equation, all right? So I can say delta x is equal to, deriving third, all right? Now we are deriving third. Okay. So delta x is equal to v0. Instead of t, I'm going to write v minus v0 by a plus 1 by 2 a into v minus v0 by a. Square means you just have to write it twice. Agreed? Okay, I'm sure you understand that. Now, well, first of all, this a cancelled, all right? Second is, you see 1 v minus v0 by a is common. You understand what is common, right? Correct? What's left behind? v0 plus v minus v0 by 2. Clear? We have taken v minus v0 by a is common, right? And then the remaining is inside the bracket. Now I'm going to take an LCM here, right? So this will be 2v0 plus v minus v0 by 2, right? Okay, is equal to. Right, now what happens next? Obviously here you get v plus v0, right? 2v0 minus v0 means v0 by 2. So this is equal to delta x, all right? 3? No, Nandini, it won't be 3. So finally you can multiply 2 and a on that other side, right? Okay, so this will become 2a delta x is equal to. Now over here, everyone, over here, if you have got x minus y into x plus y, I hope you do know that this is going to be x square minus y square, right? Okay, this is what you would have learned. So if we apply that here, we will get v square minus v0 square in the numerator, right? Again, 2 into a has been multiplied on that side, right? Okay, fine. Okay, understood, right? So this is the derivation of the third equation, right? This is the derivation of third equation, right? This is number 3. Okay, right? So now again, let me just write all of these very quickly and let me help you understand what's going on over here. It's that when acceleration is constant, right? When acceleration is constant, we can use three equations, right? Okay, we can use three equations, 1, 2, and 3, right? First one is v is equal to v0 plus at, right? This gives you relation of initial velocity and final velocity, correct? Okay, second one is delta x equal to v0 t plus half at square. This gives you a relation of displacement, acceleration, and time interval, right? Okay, and the third one, if you have a look at it carefully, 2a delta x equal to v square minus v0 square. This is giving you a relation of displacement and initial velocity and final velocity. So these are three different things, right? These are three different equations which are suitable in different cases, right? So what I mean to say is, if you have no idea about time interval, then equation 3 is suitable because here you don't see any t, right? Okay, so like that you have to choose wisely. Similarly, if you want to find displacement, then first equation is useless because the first equation is not giving you displacement, right? There is no displacement in this first equation, right? So based on what the question is, right, based on the situation mentioned, you'll have to use any of these equations, right? Okay, to find out some quantity, right? Remember the symbols. Okay, quick fire round. What is v0? What is v0? Come on, people. What is meaning of v0? Words ma જોઈએ Princey. Yes, very good. V0 is initial velocity. V for velocity. Generally, when someone writes 0 here means at start. Okay, means initial. So this is initial velocity. See, everyone, you must remember the terms also. What's V? What is V? Final velocity. Very good. Okay, right? Final velocity, right? Okay, then what is delta x? What is delta x? That is like, who is writing average velocity here? Come on, people. Won't say average velocity, Varu. Come on, it's not average velocity. What is delta x? Displacement. Very good, very good. Displacement. Not distance traveled. Warning. Okay, this is displacement, not distance traveled. Be careful. A for acceleration, of course, which is supposed to be constant, right? If acceleration is constant, only then you can use all this, all right? Otherwise, these equations are wrong. Remember that. It's a very common mistake. People use these equations only if you know that A is constant. Don't use it otherwise, right? If you don't know that acceleration is constant, don't use this. Now, whether acceleration is constant or not, that will depend on situation. So a lot of things will be based on your judgment, right? When you read the question, you'll have to make a lot of analysis and then do it, right? Physics ની બધી મજા question solve કરવામાં જ છે. થિયરીમાં તો બધા હા 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 આવડી ગયું કરી શકે. બરોબર ને? I'm sure you understand with, I mean, you agree with what I'm saying, right? Whenever we talk about theory, you all are so motivated and you all say, okay, yeah, we have understood. And then when we have to solve a question, then it gets real challenge. And it's actually a very common experience, right? Okay, that's why I know. It's not like you are, not like I've read your mind, okay, but that is very common. Okay, fine. So keep all this in mind. Again, what's T? Finally, what is T? What is T? What is T? Time interval. Yes, correct. Not time. Okay, be careful. Here T stands for time interval. Again, warning, it's not time. It is time interval. All right? Be careful with this. Okay, જો હજી કોક time લખે છે, time નહીં, time interval. All right, fine. So keep all this in mind. You have to remember this also, that you can only use it if A is constant, right? Okay, so now we are going to solve some questions based on these equations. Now, before we even get started, let me tell you that once you have studied this, as long as you study physics, you will have to use these three equations, right? These equations are called three equations of kinematics. All right? Okay, these equations are called three equations of kinematics, right? And they are going to be your companion on this physics ride. All right? Always. Every chapter. Every chapter. All right? So Priyanka explained what is kinematics very early. Kinematics means studying motion but not worrying about why motion is happening. All right? Okay. Kinematics means not worrying about cause of motion. All right? We are just studying what is happening, right? We are not studying why. That is called kinematics. All right? In next few chapters, we will also study why motion happens. All right? Then that is not called kinematics. Okay. So remember these three equations. Let's go to question. Now I want all of you to open up your exercise, all right, from the textbook, right? I'll just point out a question number and we'll do it, right? Third chapter. Okay. And we're going to do question number 6. Question 6. All right. From the exercise, question number 6. All right, here it is. Let's start. See, let's describe this situation first of all. So what's going on is that there is a car which is moving along a straight highway with this speed. All right, fine. Speed is the magnitude of velocity, don't forget that, and is brought to a stop within a distance of 200 meters. So definitely the driver is applying brakes, correct? Imagine this, everyone. Okay, this long straight road, right? No turns or anything. This is a car which is moving with a speed of 126 kilometer per hour, right? And the driver applies brakes. So gradually it will slow down, right? And it will stop. Okay. So it stops over here, let's say. So it moves from the point A to the point B, right? Okay. So here it stops, right? Here the vehicle or the car stops. So can you tell me what is its speed here? What is the car's speed over here? Yes, of course, right? Very simple question, isn't it? Very good. So here the speed is 0. Now, before we proceed further, let me tell you what is happening here. See, the velocity, I have assumed that this vehicle is moving towards the right side, okay? Okay, that's what I've indicated in this arrow here, right? So the velocity at start means at A. So again, at A means initial, right? That's what we started observing from. So at A, the initial velocity is 126 kilometer per hour. Now my question is plus or minus? Come on, which one? Plus or minus? What do you think? Why is it plus? Why is it plus? Why is it plus? I'm asking you, why is it positive? Why is it plus? Yes, that's right. The vehicle is moving in the positive direction. Ananya, I hope that's clear. Right? The vehicle is moving towards the right side and we have taken right side as positive. See, this diagram is not optional. No diagram, no physics. Remember that. Diagram is compulsory. Right? See, it's such a rough diagram. That's okay, no problem. But you should indicate such things. Where it starts, where it stops or final or something. Okay. You should specify or indicate such things in a rough diagram. Vehicle બરાબર આવું આમ મસ્ત ડિઝાઇન વાળું નહીં હોય તો ચાલશે. This is not required. Okay, this is waste of time. Clear, everyone? Just draw a very simple car, no problem. If figure is not drawn, then marks can cut. No, because you will not get marks only. If you don't draw figure, you will not understand what you are doing. All right, everyone, figure is compulsory, not for marks. Simple idea. If you want to learn physics, draw figure. Otherwise, don't join from tomorrow. It's fine, really. It won't matter. Right? Everyone, diagram is compulsory if you want to learn physics. Marks જોઈ કે નહીં તમે જોઈ લેજો. તમારે જોતા હોય તો બરોબર છે, નો જોતા હોય તો વાંધો નહીં. But if you want to learn physics, you will draw diagram. Right? નહીતર એક મહિના પછી તો છે ને એ ખબર નહીં પડે કે શું હતું. Right? હજી તો 9th નું આવે છે ને. Right? You have studied most of this in 9th. After 1 month, you will not understand anything if you don't draw any kind of diagram. Right? Diagram is compulsory, not for marks, but for learning physics. If you don't want to learn, don't draw diagram. If you want to learn, please draw diagram. Okay. So plus 126. Right. At B is final, isn't it? B is final. What's the velocity at B? What is the velocity at B? Very good. 0. Okay. Now, can you tell me what has happened to velocity? Has it increased or decreased? What has happened to velocity? First it was plus 126. Now it has become 0. Has it increased or decreased? Has it increased or decreased? Very good. Well done, people. Well done. It has decreased. Correct. So I have taught you earlier that if it has decreased, right, then that would mean that the acceleration, remember we are not talking about speed, we are talking about velocity, all right? Then the acceleration must be negative, right? I hope that is clear. Right? In fact, it is actually necessary over here that acceleration is negative, right? Okay, so what is happening here is that there is a negative acceleration. Means acceleration is towards the left side. I repeat, the acceleration is negative. That means it is towards the left side. Okay. Velocity is towards the right side, but acceleration is towards the left side here. Okay. Right? Okay. So here it says that it stops in a distance of 200 meter. So what is the retardation of the car? Right? Okay. Forget about what is retardation for a moment. Right? let's find out what is the acceleration of the car. Remember, acceleration and retardation are closely related to each other. What is that relation? I will explain it near the end of this question. All right? Okay, Nandini, very good. Right? We will find out what is acceleration and then we'll worry about retardation. Trust me, it's only one step away. All right, from there. So let's find out what is acceleration. No, Arkan, I'm not saying what is retardation right now. Okay? Because probably none of you know what is retardation actually, right? Okay, I don't think more than 2 or 3 people from the 100 that we are here, okay, would know what is retardation actually. What you have learned in 9th standard is wrong, all right? What you have learned in 9th standard is wrong. So that's why. Never mind. Let's find out A first. Come on, hurry up. Which equation should we use? See, it's given in question that it's constant. It is given that retardation is constant. So that means acceleration is also constant, right? Which equation should we use? First, second, third. First, second, third. Which equation? Third equation, JK. First, second, or third? We will use the third equation. All right? We will use third. I'll tell you why third. Think about it carefully. Think about it. What do we know? We know initial velocity. Okay. We know final velocity. Okay. Right? We also know the displacement, isn't it? So think about, if you want to find A, which equation has all these 4? Which equation has all these 4? Third, yes. See, that's why third. Okay. દરવાજો ખોલો હોય તો મિસાઇલ યુઝ કરાય. Think about it. If you want to open a shut door, would you use a missile and blast the door? You'd first try to do it with a key and a lock, isn't it? Right? If there's a lock, you'll try to find the key and open it. Correct? If that doesn't work, you might hit the door with something. But missile is the last resort. If you use missile, the whole house might get destroyed. Okay, so choose wisely. All right, everyone, please choose the weapon wisely. Okay, so third equation, 2a delta x equal to v square minus v0 square. Let's put values. 2a 200 equal to v square. What is v square? What is v square? Oh, very good. Chalo, problem nothing. Minus. Now here is where you have to be careful. Look here, everybody. It is that V0 is 126 kilometer per hour. We don't like that. Okay, we use SI units. This is not SI unit, right? So we have to convert. Okay, just a minute. Do you know how to convert from kilometer per hour to meter per second? How many of you know that? How to convert? How many of you know that? Say yes if you know it. Okay, very good. Yes, fine. Convert it. How much is 126 kilometer per hour in meter per second? Come on. How much? How much is 126 kilometer per hour in meter per second? Okay, we are getting some correct answers. Very good. All right. Fine. Yes, it is going to be 126 into 1000 divided by 3600. Or you could also remember that this cancels to 5 upon 18, right? If you want to remember that, then 18 into 7 is this. So 7 5s are 35. All right. Okay. So find out what is A now. Hurry up, people. I want answer in fractions. Okay, I want answer in fractions. Find out what is A. I want answer in fractions, everybody. This is 200. Simplify that fraction, Ami. People, I said I want answer in fractions. What are fractions? What are fractions? And simplify that fraction. આટલું મોટું ન જોઈએ મને. Simplify it. Simplify that fraction. No, me fraction. Raj, fraction કોને કહેવાય? Fraction. અરે ભાઈ, fraction people. અરે કેન્સલ કરતા આવડે કે નહીં તમને? કેમ આવું કરો છો યાર? 1225 with a minus sign divided by 2 into 200. કેન્સલ કરતા આવડે કે નહીં? હે? આવું નથી આવડતું? આવડે ને? Clear? Oh, sorry. 2 and then you have 22, so 4 and 5. Right? Okay, then all right, so we get minus 49 by 16. 3 ક્યાંથી આવ્યું કાવ્યા? 49 by 16 is 3. Okay, so this is your final answer. All right, minus 49 by 16 meter per second square. See, this is not a surprise. મેં તો પહેલા જ કીધું હતું, acceleration will be negative, yes or no? Right? Before we even started, I told you that acceleration will be negative, right? And that's not a surprise at all, right? In fact, what has happened is maths is only proving what we were thinking, right? We were thinking that acceleration will be negative because velocity is decreasing, and that's what we have, right? Okay, fine. If you want, you can then divide it, right? For your kind information, in JEE or NEET exams, calculators are not allowed, all right? So you have to divide it like you used to do in 10th, everyone. Clear? In board exams, it is allowed. Let me tell you. In board exam and good set, that's allowed. Okay? Clear? In JEE and NEET, it is not allowed. So you should learn to do it without calculator, right? And yes, many of you have, many of you have got it right. It is minus 3.0625 meter per second square. Right. So this is acceleration. All right. See, let's continue now. What is retardation? Right? What is retardation? Time to know that. No, Nandini, it's wrong. See, that's why I said don't try retardation. Don't try retardation, my dear friends, because most of you don't know what is retardation. It's okay. Most people learn it wrong from 9th standard. Arey Riya, maaf karo. Okay, negative acceleration is not retardation. All right, everyone. So here is the meaning of retardation. Listen to this carefully. This is a very important point. Please write it. If velocity and acceleration are in opposite direction, if velocity and acceleration are in, તમે લોકો ચૂકી જવાના હો, હું તમને ના પાડું છું. Do not write your answer. Focus on what I am explaining. All right? You will not be able to understand this. I hope everyone will be careful. All right? Please don't write about retardation. You don't know what is retardation, right? If velocity and acceleration are in opposite direction, like we had here, right? We had it here, correct? if you look at this, the velocity was towards the right side, but acceleration was towards the left side, negative. All right, positive velocity, negative acceleration, opposite direction. So if velocity and acceleration are in opposite direction, speed of object decreases. I'm saying speed, I'm not saying velocity. Okay, I'm saying speed. When I say speed, I mean speed. When I say velocity, I mean velocity. They are different, right? So if velocity and acceleration are in opposite directions, speed of the object decreases. Fine. That's what happens when we apply brakes. Okay, right? Okay, so such motion is called retarded motion. Okay, such motion is called retarded motion, and in such situations, okay, in such situation, that is when the speed is decreasing. When the speed is decreasing, we say that magnitude of acceleration is equal to retardation. This is its only correct definition. There is no other correct definition. All right. This is the only correct definition. That is, when speed is decreasing, you find the magnitude of acceleration. That's called retardation. All right. No, Vedant, there is no difference. Right? There is no difference. But that difference is very important. There is no other difference, but the difference is very important, right? Okay. So if you have a look at what was going on in this question, is that the vehicle, first of all, its speed was 126 kilometer per hour, right? It's more, isn't it? Gradually, as brakes are applied, the speed will decrease. So it will slow down, right? It will slow down, and over here its speed will become 0. At that point, velocity is also 0, right? Is that okay? Both are 0. Now, what is happening is, look at the speed. Fast, here it was fast, and here it is slow or has stopped. Agreed? So it means its speed has decreased. So we can say that this car is doing retarded motion. The car is in retarded motion. Clear? The car is in retarded motion. Okay. Now, what is the retardation? When such things happen, in such situations, magnitude of acceleration is equal to retardation. This is its only definition, right? So what is retardation in this question? What is retardation? It is magnitude, means modulus of acceleration. All right? Yes. So now let's put the value. Okay. So finally we can say that the retardation is 3.0625 or 49/16, as you want to write. Okay, no problem with that. You can write it in either way. Okay, generally in board exam you should write like this, right? But you should also know fractions, because you don't get calculators in JEE NEET, so fractions are important, right? So this is your answer for retardation. All right, either way. Unit will be same, yes, because there is no symbol of retardation, it will be confusing if you take a symbol. We use it very rarely, okay? It's not like in every question we have to talk about retardation, so there's no symbol. All right, so the retardation is 49/16. Again, a word of warning, everyone. Word of warning: negative acceleration is not retardation. All right, be careful. Negative acceleration is not retardation. Be careful with this sentence. Yes, and you can only define it if speed is decreasing, right? Retardation, we should only talk about retardation if speed is decreasing. Otherwise, retardation means nonsense. All right? Otherwise, retardation means nonsense. Okay? So that's the whole thing about retardation. All right? Please keep this in mind and please forget what you know from 9th standard. This sentence is very important. Okay, everyone. Negative of acceleration is not retardation. You don't have to keep retardation in modulus arcans. You have to put acceleration in modulus. Then that gives you retardation. Right? Okay. So now let's find the answer to the other part. Let's find the answer to the other part. This part. Here. How long does it take for the car to stop? How long means what is to be found? How long? How long means what? Time. Yes, correct. Yes, well done, Nandini. Time. Very good. Okay, we have to find time interval. Yes, correct. We have to find the time interval or time after which it will stop. Correct? So which equation suitable? Which equation? Think about it. What do we know? We know initial velocity, we know final velocity, we know acceleration. Which equation is suitable? First equation. Very good. First equation. Do it, come on, and find the answer. Hurry up, please. Hurry up. You do it on your own. Okay, I'm not doing it. You do it on your own. All right? Are you sure, Harsh? 400 seconds? બહુ વધુ વાર ન થાય? Okay, very good, Ankita. Well done, Priyansh. Well done, Nandini. Yes, very good. Heli, write the unit, please. Please write the unit. Okay. So it's going to be about 11.4 seconds, correct? That's what most of you are getting it. Okay, Pinak, you're getting a different answer. That's very interesting. I'll just take a moment to do it. Here we go. This will be 35, v equal to v0 plus 80, 0 equal to 35 plus minus 49 by 16 into t. All right? So therefore, minus 35 equal to minus 49 by 16t. Minus minus cancelled. All right, this cancels with 7. So t is equal to 80 by 7. 80 by 7 is 1. And then 1 point. And now we have 30. So 4. Yeah, nearly 1.4 seconds. All right? 11.4 seconds. Yeah. Clear? So that's how you do it. So it means it will stop. It will stop after 11.4 seconds. Clear? It will stop after 11.4 seconds. Clear? Okay. Now, let's solve one question from the textbook. I think it's an example. So we're going over to the example number. Number 4, 3.4. All right, we're going to do 3.4. Don't worry about example 3.3, right? We are not following order, right? Example 3.3 will be one of the last things to do in this chapter, right? We're going to do 3.4 now. Now, this is actually a little bit like the questions that you would have solved in 9th standard, right? It's a bit like questions that you have solved in 9th. Okay. So as usual, diagram is very important. Okay, without diagram you will not understand anything, right? So let's start drawing it. So it says that a ball is thrown vertically. Vertically, that is like this, straight up. Okay, vertically upwards, right? So straight upwards. Fine, I think you all understand that. With a velocity of 20 meter per second, right? So what that means is from some point, let's say from here, we're throwing this ball up with a velocity of 20 meter per second. All right. From the top of a multi-story building, that is a tall building, right, with lots of floors. So how to draw that? Well, fairly simple. This is good enough. It's okay even if you don't know the man or the person who is drawing the who is throwing this out, right? It's okay. Who has thrown the ball? We don't know, right? Don't worry, right? We are not interested in who is throwing the ball. Okay, that's what I'm saying. You don't need to make an exact diagram. Rough diagram, very good. So the height of the point from where the ball is thrown is 25 meter from the ground. And it is common sense to assume that ground is at the lower point of the building. Agreed? બરાબર ને કે હવામાં હોય આવી રીતે હોય બિલ્ડિંગ. Right. So of course it's over here. Now what's this height? What is this height? It's 25 meter, correct? This height is 25 meter. Yeah. Okay. Now A, how high will the ball rise? Now first of all, what's going on? Let's talk about that. See, when you throw something straight up, what happens is that it will rise straight up to some highest point and then it will fall down. Agreed? Like this. Is this clear? It will go up and then come back, right? See, we are not throwing at an angle, so it will not go like this. Okay, not like this, because this is thrown at an angle, right? Then that would happen. But if you throw it straight up, it will go like this and then fall back to the same point. Fine. Okay, so we have to find how much high will it go. How high will the ball rise? That's the question, right? So from where, that we don't know. We could actually do it from anywhere, no problem, right? We could actually do it from anywhere. Yes, it's like a projectile. Correct. Projectile means to throw. See, not so fast, everyone. Please don't try to go ahead of me. You're going to be in a lot of trouble. Okay, let's take it stepwise. It can get very confusing. So we are saying that we are throwing this ball from the point A, right? It goes to the highest point B and then returns to A or something. All right, we don't know that. We have only read till here. Okay, બસ આગળ નહીં જશો. બસ અહીંયા ભરી જાઓ. Stop here. Okay, we don't want to worry about B right now. Just worry about A. How high will the ball rise? And take G is equal to 10 meter per second square is given. Now I want all of you to understand some basics. Listen to this very carefully. Whenever something is in the air, okay, without support, right? For example, you are throwing a stone or a ball, right? Okay, but yes, we are not talking about things that have engine and all that. Okay, we are not talking about a rocket or a plane, or we are not even talking about a bird, right? Because all these things, they are actually pushing air, right? They all move by applying forces on air, right? Okay, so we are not talking about such things that have an engine, or we are not talking about birds. We are talking about things that we throw typically. What do we throw? We can throw a stone, a ball. We can also throw a person. All right, no problem, right? Okay, so that's what we are talking about. So whenever we throw such things, all right, whenever we throw such things, I'm sure you understand that Earth attracts everything, right? Right? Earth attracts it. So that when, oh sorry, just a minute, because Earth attracts it, it gives every such object a downward acceleration. I'll repeat, you can write this, it is very important. Because Earth is attracting everything by gravity, right? Earth has gravity. So because of that Earth's gravity, there is a downward acceleration. Clear? Downward means in the downward direction. All right, don't forget. Below, vertical down, right? There is a downward acceleration. Clear? This downward acceleration has magnitude. This downward acceleration has magnitude g. We call its magnitude g. Remember, right? So this is called acceleration due to gravity, right? In physics books, you are going to find it this word, acceleration due to gravity. How much is that acceleration due to gravity? Its magnitude is g. All right, its magnitude is g. So how much is g? 9.8 meter per second square. That's what you have learned. All right, I'm sure you have learned that in 9th standard. Yes, but listen to this carefully. For easy calculations, see, this is the correct value. Let me tell you, this is the correct value. But for easy calculations, we often take g is equal to 10. All right, we often take g is equal to 10. Clear? So that numbers are easy. Minus ને બધી વાત હું નથી કરતો, વેદાંત. I am coming to that point. Okay, right? Again, everyone, magnitude is this, or 10. Oh sorry, the magnitude is 10. All right, I'm not talking about acceleration, I'm talking about magnitude of acceleration. Don't forget, right? Okay, so now when you are solving a question, just like we used to take, if you remember, we used to take one direction. Arey yaar, chat box band karo. Who found the value of g? That is not important right now, Priyansh. Okay, everyone can do it by using a pendulum. It's not a big problem, right? So if you want to study motion on such axis, we used to take one direction positive and one as negative. You have to do that. Just like that here, when the ball is going up and down, the ball is moving in vertical motion. Is that okay? But it's still motion in straight line, right? If you throw it exactly vertical, angle per nahi, not like this. All right, that's not what we are talking about. So in such a case, you should take one direction positive and one direction negative. Typically, we take upward positive and downward negative. Is this clear? We take upward positive and downward negative. All right? Fine. Okay. So if you do that, listen to this very carefully. If you take it like this, if you take it like this, all right, like this diagram, vertical, then the acceleration due to gravity is a equal to minus 9.8, or you could also write it as minus g, and unit meter per second square, all that. Okay, no problem with that. Is this clear? Okay. what's this minus sign for? What is this minus sign indicating? What is that minus sign indicating? Whose direction? You all are writing direction. Whose direction? Whose direction? No, Vedant. No. Bus jo. Well, see, everyone, listen to this carefully. Now don't answer it. All right, I got it. What you're saying. I got what you're saying. This minus sign is actually indicating the direction of acceleration. People, it is not indicating direction of ball. All right, is that clear? Also, it has nothing to do with opposite. Ball may be going up or down, it doesn't matter, right? Earth will attract ball in which direction? Downwards, correct? Earth will always attract the ball downwards, agreed? So this acceleration is always downwards, and because we are taking downwards as negative, that's why we are putting minus. This has nothing to do with the ball. Again, okay, nothing to do with ball. Remember that sentence? Direction of motion has nothing to do with direction of acceleration. યાદ છે ને આ કે નથી? Do you all remember it? So that's what we are talking about. Acceleration is downwards. Ball may be going anywhere. Nobody cares, right? Right now we are talking about acceleration, and acceleration is downwards. So it's negative. Simple. Got it? All right. See, again, I will remind you, when I write a sentence for you and ask you to remember it, I've said it earlier, I'm going to repeat it. It's tremendously important. નહીતર હું લખું જ નહીં. મને કોઈ છોક થતો નથી તમને સેન્ટેન્સીસ લખવાનો. Okay? Right? And you should not mug up those sentences. You should also understand what it is saying. This was a chance to use that sentence, right? Isn't it? Direction of acceleration is negative. Ball may be going anywhere. Okay, so with this in mind, we are going to continue with this question tomorrow. We are already late by 3 minutes. All right, we will continue with this tomorrow. All right, draw this diagram. You can try it if you want. Okay, please try, no problem. You can try it. It will be very good for you. All right, yeah. Goodbye, everyone.